the angle addition postulate and angle bisector notes. Okay, in yesterday's notes we talked briefly about this angle the angle addition postulate, and the big thing that we came back from that was you have your part plus part equals whole. You're also looking for this word interior. That interior tells you I need to do part plus part equals whole. So in this picture, it tells us that P is in the interior. So that means this point right here is going to end up being P. And it's going to be in the interior of the whole entire angle, RST. What is this part of the angle called again?
The bisector.
Vertex, careful. Vertex, right? What letter, when I'm reading the name, what letter out of R, S, and T goes with the vertex? Why? It's in the middle. Perfect. So that S is going to go right here. The R and T, I don't care which side it's on. Remember, you can name it both directions as long as that S is in the middle. So here we have R, here we have T. Usually I do P plus P equals W, but because we already have a point P here, we're going to go ahead and make sure we remember this is one part, this is your other part, and then we have the whole entire big super duper angle there. Yes, sir. P is point P is in the interior. But thank you. Do you understand? Okay, thank you very much for asking for clarification. I'd rather you guys ask than be confused. So, the first example we have is just going to be based on what we did yesterday on the back side. We're just sticking with numbers. Okay? Here we're going to have W is in the interior. Ooh, we need to highlight that. The interior of angle XYZ. Then they're going to give us some information and ask for some other things. With these bullet points here, we need to make sure we're going through, and let's see. We need to first draw and label our diagrams. This is very important, especially when you need to substitute back in, plug in, replace X. You know exactly which one you're plugging in for. And we had a lot of errors on this on the test where we understood, hey, I got to substitute in, but you substitute for the wrong one. Okay, so we need to go ahead and, if it's not there, draw and label. So we have the interior of angle XYZ, meaning XYZ is the whole. So we're going to go ahead all the way over here, so we have room over here to work. We'll go ahead and label, draw and label angle XYZ. And we're going to write those letters in that order that we drew. Okay, remember the middle letter is always at the vertex. So we can have point X up here, point Y is going to be at the vertex, and then point Z. W is somewhere in the interior, in that inside, somewhere here, right? So we'll go ahead and we'll write in a point W. But we also need to make sure that we draw the ray. Because right now, if we only have that point, we still only have one angle. So we need to create our part in our part. We have our whole. So we're going to draw our ray through point W. So here, again, I think we saw this on the other notes, we're not always going to have ray whatever is on the interior. Sometimes it's just a point and we have to draw that ray in. Okay? So they're going to give us a bit of information here. They're telling us that angle X, the measurement of angle XYW is equal to 52 degrees. So we go find those letters. XYW, meaning this part right here, is 52 degrees. So let's go ahead and label that. We're also told that the measurement of angle XYZ, is that a part or a whole? It's going to be the whole thing, okay, is 79 degrees. A lot of you probably already know exactly what to do, okay, but we're going to go step by step through here. What this problem is asking us to find is the measurement of angle WYZ. The only one we don't have, right? So that's going to be this angle right here. Highlighting the actual part that they're looking for on the picture is important whenever you're dealing with the algebra, whenever you have to solve for variables, etc. Okay? So if we look over here at our bullet points, we already drew and labeled. Let's write our math statement, or it's also called math sentence. What I mean by that is your part plus part equals whole, but using these angles. So the first thing, our first part, is going to be the measurement of angle X, Y, W. So we're writing the measurement of angle X, Y, W, the first part, plus what? The measurement of what? Angle, good, angle, W, Y, Z. You know what? Honestly, I need to lay off the fact that you guys aren't saying angle. As long as you got those letters and you know what we're talking about, that's important. This is all going to be equal to the whole. So the measurement of angle what? X, Y, Z. Good. Equal. Part plus part equals whole. So thank you for asking. So we wrote our math statement or math sentence. Cool. Awesome. Now what we're going to do is we're going to substitute in for what we know. All right? Well, according to the information they gave us, we have the measurement of angle X, Y, W right here. So we can substitute in for 52 degrees. We're going to add the measurement of angle W, Y, Z, but we don't have it. Now, usually when we use an X, if you want to put an X, please do. The only reason I'm not is because, dang it, there's an X in the problem, on our angle, right? So if you just want to put an X so it's clearer for you, put an X. Here, I'm just going to rewrite that measurement of angle W, Y, Z. This will be equal to what? You're a step ahead of us. 79, the measurement of angle X, Y, Z. But Xavier's got that for us already, right? 79 degrees. In the end, a lot of you probably already saw, all I'm going to do is subtract. And yes, so if that's the way you choose to do it, there's nothing wrong with that. Just show me what you subtracted on your work. Okay, show me what you plugged into the calculator. So here, we know this right here, even though it looks different, again, if you put an X, it makes more sense. We need to isolate this so we can find that measurement. So how to do that? We subtract that 52 from both sides, and we're going to find out that that measurement of angle WYZ, what they wanted us to find, was 27 degrees. So it's, again, just using the numbers. We're going to step into now using algebraic expressions, okay? And what we're doing there, it's the same thing we did with segment addition postulate, okay? So we're going to take a look at a couple different problems. You're also going to see another vocabulary word that you were introduced to yesterday pop up here that you're going to realize, ooh, I do need to know what that means. Okay, that'll be on the example number 3. Now, example number 2, given that M is in the interior, ooh, that's a word to highlight, interior, so I know I'm using part plus part equals whole, of angle LKN. Thank you, problem, for writing, drawing the picture and labeling it for me, because I don't have to do it now, right? So we have that M is on the interior of angle LKN. We see here that the measurement of angle LKN is equal to 150 degrees. So what that means here is this entire degree measurement right here is 150 degrees. I'm going to use the 3 different colors. Pretty detailed on this problem. I'm going to kind of drop off a little bit of the colors on the last one, okay, because it takes a long time to switch between our colors, right? We need to see our part, and whole. And instead of outlining the entire sides, I'm just going to kind of scribble in here. There's one part, a lot less time, right? Here's another part. And then here we have the whole. Again, thank you for those of you who did read the board and knew to have those colors out already. So in the end, when the last part that it says here is that we want to find the measurement of angle MKN, always good to highlight that. And then, especially because we have that variable in there, okay, we've got to solve for x first, I'm going to go over here and I'm going to find angle MKN and do a little bit of highlighting. And it's going to kind of cover up our colors That's why I did the colors first. Okay? This is what we're finding in the end, is this angle right here. That's what we'll substitute in for later. So we need to remember here that we're going to have our part plus our part all equal to the whole. And this problem will probably take the longest with writing stuff, with switching colors, if we are switching colors. We're going to now write the math sentence. Okay, I'm going to continue using my corresponding colors. What does corresponding mean? Matching. Perfect. Okay, so I'm going to use my matching colors. My first part, I put in pink. So I'm going to go find that angle, right? So we're going to take the measurement of angle LKM, or whatever color you did, your corresponding or matching. So we're going to take the measurement of angle LKM. We're going to add the other parts, which will be the measurement of angle what? MKN. I hate it when they have an M and an N. It's like M as in Mary, KN as in Nancy. All right, so MKN. So we got our part plus our part. Now we're going to equal it to the whole, which is the measurement of angle LKN as in Nancy, right? So we've written our math sentence or math statement. Now we're going to go through and substitute in for what information they gave us. On our picture, or diagram, what is the measurement of angle LKM? 2x. Plus, what is the measurement of angle MKN? 4x, good. All set equal to the entire thing, the measurement of angle LKN. That 150, good. So now we need to go ahead and solve for x. What do I need to do first here? We got to combine our like terms, which in this case we have our x's, right? So let's go ahead and combine these two guys together. How many x's do we have? Good. 6x, all equal to that 150. So what?
Do we divide?
Absolutely. That is our last step here. We're going to go ahead and take both these, and we're going to divide each side by that coefficient. What's in front of x? I'm hearing some answers that are... If you divide 150 by 6, you're going to get 25. Very good question. Is this 25 degrees? The answer is actually, I think you just answered your own question. No, because it's x. And x is not one of these. Once we actually substitute it in, then we will have degrees. Now, if this was just x instead of 2x, then yes, because that would be the straight-up degree measurement. But because we have to substitute in yet, we don't have our degrees yet. Very good question. Yeah, it's always this class. That's the greatest questions in the world. Is this what we wanted? No. Well, kind of. We needed it, right? Now we got to substitute it in. So we're going to take angle MKN. All right, so the measurement of angle MKN. That was a really bad N, sorry. We have here is 4x, right? So we know substitute, plug it in, replace, okay? We're going to take out that x, and we're going to substitute or replace it with that 25. Now, if you don't, that arrow right there that I keep drawing in the notes, I need you to understand why I draw it. In case we are still a little foggy on the substitution, and you go look at your notes later and that arrow's not there, you might say, wait, where'd 25 come from? So that's why I draw that arrow in the notes. So we can say, oh, it's when we solve for x. Okay, I got it. All right, so if you don't need that arrow, don't put the arrow. I don't expect to see the arrow in your work either. Okay? So then we're going to come up with the measure of angle MKN. Well, that's like saying we have 4 quarters. A quarter is 25 cents. So if we have 4 quarters, how many cents do we have? 100. Makes $1, right? So we got 100. Now we'll put that degree. So here is your next step, having that algebra in there. Now, the next problem is going to bring in another vocabulary word. We talked about vertex, right? We need to take a look at example number 3 and see, and highlight, given that angle KLM is a what? Straight angle. Ooh, see, I told you yesterday, I said it's going to say straight angle, but it's not going to tell you how many degrees. It's going to say right angle. It's not going to tell you how many degrees. So, what is a straight angle? 180 degrees. If you're kind of like, oh, I better put that there, just remind myself, okay, that goes with straight angle. So that means angle KLM down here. Now, we never assume, okay, we never ever assume. Bringing up assumptions, I'd assume a really good question asking, well, isn't angle up here on example 2, isn't angle MKN 90 degrees? Isn't that a right angle? So, well, how do you know? It's like, well, it looks like it. Nope, unless they tell you or unless they have that box. You cannot assume, okay? But here they're telling us it's a straight angle, so we don't need to assume. We're given the information. So down here, this entire angle right here, angle KLM, is 180 degrees. The only one thing they did not label for us. We are going to have our part plus part equals whole again. Just the only difference between this one and the previous one was, well, we've got a little bit more we're going to have to do algebraically, and we're bringing in that straight angle. Okay? So I'm just going to use the colors to kind of color in the angles. And that's it. So we have our part, and whole. Mm-hmm.
That's a positive to that, right?
Yes, because there's no negative in front of it. Yep. So here again, we'll have our part plus our other part, all equal to the whole. Now I'm going to drop off the colors here. Okay, I'm going to drop off the colors. I'm just going to stick to my black pen / what would be the pencil. Okay, if you want to keep going with your corresponding, or what's corresponding mean? Matching colors, you can, but I'm going to save some time with this. We're going to go ahead and we are going to write out our math statement though. Our first part right here, we have the measurement of angle what? What's our first angle here? KLN, so the measurement of angle KLN. We're going to add the measurement of angle. Got one person there. I know you guys got it. NLM. All equal to the measurement of our whole angle, what? KLM. That's the most one of the most time-consuming things is sitting there writing all that out. Part plus part equals whole. That's the formula. So we have our part plus part equals the whole thing.
Wait, so it's KLM plus NLM?
KLN plus NLM equals KLM. The whole thing. Guys, it's just like this, except for our whole is a straight line. Okay, I know it's a little bit harder to see on this one. Okay, are we all on board?
Yes.
Everybody got it? You're already calculating. Why are you shaking your head no?
Oh, yeah.
So let's substitute in here. The measurement of angle KLN is what? Good. 10x minus 5. We're going to add. Substitute in for the measurement of angle NLM. 4x what? No, why is everybody say 3x? 4x, that's just odd. So many of you said 3x. 4x plus 3. We're going to set that equal to the whole 180. Good. So I see that I'm probably going to have a lot to do. If you don't draw the line, you don't need the line for the algebra, don't draw it. Okay, but I see a lot that's going on, and if we're kind of still struggling with the algebra, solving for x, then we might want to draw that line. We need to remember that we need to keep the equation balanced. We're not adding something twice to one side. Okay, that's what I'm seeing. We need to make sure, like I'd have a student say, okay, minus 4x, minus 4x. No. Then you got 2 minus 4x's on the exact same side of that line. Okay, this is where we need to do the combining like terms first. Okay, with our steps, we have no parentheses, but we do need to combine our like terms.
What do you get? The combined like terms are 14x.
Well, hold on. Let's go ahead and take a look at it. But thank you. I know you got this. So we're going to combine this 10x, positive 10x, with our positive 4x, right? Do we have any more x's over on the right, on the left-hand side we need to combine? No, we're done. And what are we going to get? 14x. We were already told. And then we need to make sure we combine our constants. Constants are the numbers without the variable, without the letter. Now pay attention. We have a negative 5. Once we pull the term out, that minus, the double agent, turns into a negative. We have a negative 5, and we have a positive 3. So if you put that in your calculator, negative 5 plus 3, what are we going to get? We're going to get a negative 2. So I take that negative 2, I put it back in the equation. That double agent is now turned to a minus 2. Same thing. Okay? All equal to 180. So we've got variables to one side. We only have variable on one side, but we do have constants on both sides. So what's my next step? Add that 2. Good. Add that to both sides. Cancels out on the left. We're left with 14x equals that 182. And the last step we do here, 99% of the time in geometry, when we're solving for x, we're going to divide both sides by that coefficient. What's in front of x? Good. And x is going to be 13. Now, we go back up and we look. They wanted us to actually find the measurement of both of those parts. We don't need to find the whole. We already know the whole. So what we're going to do, instead of writing it out like we did right here with the measurement, blah, 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 write it, then substitute, and yada, yada, we're just going to go ahead and do it right here, just straightforward. Okay? What I mean by that is we're going to take that 10x minus 5. We're going to take that 10, take out that x.
You put 13.
Is it not 13?
No, I
No,
said
it
you
is.
put 13.
Yeah, okay. I was like, it is 13. So we're, hold on. We're going to plug in that 13, and then we're going to find that measurement. So the measurement of this first angle, KLN, we're going to calculate that out. I see several of you have already done that. Thank you. And what is this measurement going to be? Good, 125 degrees. We do not want to take that and subtract it from the 180, because what happens if we incorrectly solved for x? Okay, so we need to plug it in. I'll show you guys the double checking. Jordan, pay attention. So right here we've got the 4x plus 3. We'll do the same thing. We've got our 4. We're going to remove that x. Plug it in with that 13. Again, if you don't need those arrows, don't worry about it. It's just to help for if we're having substitution. We need some more substitution to help. And the measurement of angle NLM, when we do all of our math, good, we're going to come out with 55 degrees. Now, when you have a right angle or you have a straight angle, or you'll see in a moment how we can also check our work on the next side, you can always double check the work and say, did this work out correctly? Did I find the correct, well, did I solve for x correctly, and did I substitute correctly? So up here we can write how we're going to double check this. How do you think you double check it? Yeah, See if they add up. Add them together. Take that 125 plus that 55. Does it add up to 180? Cool. Now, if it does not, don't erase everything and start over. The first thing you need to do, make sure that you use the correct algebra and you didn't actually put 5 here or something. And if you did do it correctly, double check the math in the calculator, little steps. And then if you double check the math and you're still getting the same numbers, then go back and look through and try to find where your mistake was on X rather than just starting all over again. Okay? Yes.
All this is gonna like eventually come together, right?
Yep.
So I'm not confused how it's connected.
You'll see. We're not there yet. All right, other side. We have our angle bisector now, just like we had a segment bisector or a midpoint. Okay, it's something we're going to need to make sure that we understand. This is why we highlight our words. Joseph, get your head up, please. With an angle bisector, we're going to have a ray that divides an angle. So we're going to have a ray that divides an angle into two, they put too many words here, two congruent angles. It says two angles that are congruent, but it's going to cut that angle directly in half, okay, so where we have two congruent angles. So when we see that ray, we see that word bisects, we want to make sure that we highlight that so we understand we have now two congruent angles. Interior, no, not two congruent angles. And so here we have congruence. What's going to happen in these pictures that you're going to have to see or draw are going to be little, and they're kind of hard to see, but are little arcs here. Okay? Just like with a segment, when we had a midpoint or segment bisector, we had tick marks. With the angles, we draw these little arcs in there. Okay? So let's jump straight into the first one here. We have that ray LM. Oh, there's that word bisects. I know I'm going to have two congruent angles. It's going to bisect angle WLJ. That tells me WLJ, that angle, is the entire big thing. Okay? So we'll go ahead and draw in angle WLJ. Putting our points in there where they belong. Making sure the L is at the vertex. And then we need to draw in ray LM. So all we do is we start at our vertex M, and we can just eyeball it. We're not going to measure. Okay, we'll just eyeball a ray, and we're going to place that point M on there. Now, if you had none of these words, and you had just this picture, you do not assume that they are congruent. So in order to show somebody with just the picture, and that's it, that these are congruent, that's where we need to draw those arcs. So because this is bisect, we need to draw an arc in each one of these parts. Now if I give you just the picture, now you know they're congruent. And when two angles are congruent, what do you know about their measurements? They're equal. Yes, the same, but we want to get used to hearing that if two things are congruent, their measurements are equal. Okay, because that tells you how to set up whenever you have algebra. So the next thing we're going to look at is finish labeling what we have. In the problem, I see here that the measurement of angle WLM is equal to 40 degrees. So WLM, we're going to go ahead and label 40 degrees. We want to find the other part in the whole. So we were going to find the measurement angle MLJ and the measurement of angle WLJ. And I know a lot of you already know what's going on. Everybody's got, I'm already hearing it from you guys. I'm hearing it from you guys, all right? We're going to write a little something in here, though. Okay? We want to remember that the measurement of angle, we're doing our two little parts, WLM is equal to the measurement of angle what? MLJ. Why do I have an equal sign and not a congruent sign?
Because
They're measurements. Measurements are equal, okay? So, with that being said, we can do our three little points. Therefore, meaning, well, because of this, we can now conclude that the measurement of angle MLJ, one of those that we want to find right here, is what? Just the part. 40 degrees. How do we know? And how do we know that they're congruent? We drew in the arcs. We know they're congruent because that was very, very good responses from several of you. We know they're congruent because of the arcs. Why did we draw those arcs? That bisects. Okay? So here's one of your answers. And yes, you have a part plus part equals whole on this one. But because it's bisect, you also know that you can just double it because they're exactly the same. Okay? When we take a look at the measurement of angle WLJ, the whole part, and I am sort of doing the part plus part equals whole, but I'm doing it backwards. We're doing the whole equals part plus part. Is going to be equal to, let's go ahead and label our other angle here real quick. Sorry about that. Forgot. So the measurement of angle WLJ will be equal to our part of 40 plus our other part of 40, or just multiply it by 2, giving us a total of 80 degrees. Okay? Total of 80 degrees. So let's try it with some algebra. We're going to change example 5 a lot. Because example 5 is very long, there's not a lot of room, and it's going to take forever. So I'm going to kind of cut it down a little bit. Number 1, we already dealt with a straight angle on example number 3 on the other side. Okay? So we're going to go ahead and just ignore all this. Because what they actually want us to find is the measurement of angle IFE over here. And you've got to do a lot of work before you can do that. Then you actually have to do a part plus part plus part equals whole. But you have to solve for x first, substitute it in, and then do a whole other variable over here. Screw it. Let's cut straight to the chase. We are going to ignore ray FI because we don't need that.
So that entire part?
That entire ray FI and this entire the straight angle and find IFE. Okay? It does not say it up there. I don't think we really need to write it up there, but what we're going to be doing is we are going to find both these angle measurements. Okay? So what we need to first start off with is reading here, okay? Ray FG bisects, so we know something that's going to happen here. Bisects angle EFH. So with that word bisects, what should we do to our picture? Draw those little arcs in there, saying these are congruent. So if the two angles are congruent, their measurements are equal. There you go. The reason I say it is because we put the equal sign. So if they are congruent, the measurement of angle EFG is equal. That's why I have you guys say equal instead of the same. To the measurement of angle GFH. 1 second. What's up?
How are we supposed to
Solve?
Yeah, because if you don't want us to take into effect that it's a straight angle.
We're ignoring that part. What we're looking at is if two, and it's a very good question, if two angles are congruent, their measurements are equal.
Right.
We set them equal to each other. If you substitute in the information you have, you substitute in the information you have, let's look here. This is our math statement. They're just equal to each other. So, what's the measurement of angle EFG? 5x minus 10, right? So we have 5x minus 10. We're going to set it equal to its congruent angle measurement, angle GFH. So it's equal to what?
3x plus 25.
Good. 3x plus 25. So, we need to go ahead and solve for x here. We have variables on both sides. Which one should we move? Let's get rid of that 3x. It's smaller. Less chance to deal with negatives. This is where I say I'm going to speed up on that solving for x. We subtract that 3x from both sides. What are we left with?
2x minus 10 equals 25.
Good. 2x minus 10 is equal to 25. Next.
Add 10.
All right. Going to add that 10 plus 10 to both sides. We're going to get 2x equals, I just heard it, 35. Told you guys I'm speeding up on this stuff. Right, you doing all this? Visual looks completely blank. You got a video to watch later. Next, we're going to divide by 2.
17.5.
And we are going to have that decimal. Remember, in your calculator, we can do 35 divided by 2 decimal. Okay? And that'll tell the calculator, hey, I want a decimal. Or 35 decimal divided by 2. So we're going to get that 17.5. So we're going to substitute in for both of these and make sure that we did solve for x correctly. Now, granted, the fact that I'm your teacher and I walked you through it, yeah, we probably did, right? But let's go ahead and take a look. If we take that 5x minus 10, we're going to replace the x with 17.5 minus 10. I'm going to make that a little bit prettier. We're just substituting in. So we're substituting in that x. Forgot to change colors on that one. And we're going to do the exact same thing for angle GFH. We have 3 times that 17.5 plus 25. When we calculate these, because of bisects, because of congruent angles, we should get the same number. If we do not, go back and do what I said earlier. Double check to make sure that you copied the algebraic expression correctly, that you plugged in right. Make sure you calculated it correctly in the calculator. And if you did, then go back and start walking through solving for x and see where your error was. So the measurement of angle EFG and the measurement of angle GFH, did we get the same number?
Yes.
Good. And what was that?
7.5.
Perfect. The next problem, we're going to ignore the straight angle because I don't even know why it says that. It's not even part of what we're going to be doing. Okay? We're going to get through this one pretty quickly. Okay? We see this bisects. So we're bisecting again. We're ignoring ray FI. And because of that bisect, we know that we have 2 congruent angles. We're going to label what we know. They gave us that the measurement of angle GFH, so GFH is 3x plus 20. And they told us that the measurement of angle EFH, oh, that's the whole entire thing, is 4x plus 80. We want to find the measurement of angle EFH, that whole thing. So we have to solve for x and substitute it in. But how on earth am I going to solve for x? What you got, Gabriel? Okay, so you have this option. Multiply it by 2. Why? They're congruent, so their measurements are equal. So EFG and GFH are both 3x plus 20. So if you want to do it a distribution way, you can do that, or you could just do your part plus part equals whole. So where both of our parts are exactly the same. So we have that 3x plus 20 plus another 3x plus 20. Or again, if you want to do a distribution, where you just take that 2 on the outside and 3x plus 20, okay? You have that option too. I'm going to erase that though. But that is an option if you're good with distribution. If you mess up on distribution, don't use that, please. Okay? And this is all going to be equal to the whole of what?
4x plus
Good. 4x plus 80. We got a lot of stuff going here, so I'm going to draw my line. Again, if you don't need it, don't use it. What do I need to do first?
Minus 3.
Now, combine like terms. Positive 3x, positive 3x. How many x's do I have?
6.
Good. 6x. I have a positive 20. I already heard it. Good. And a positive 20. I'm going to get a plus 40. Nothing's going on the right yet.
You subtract the 40.
You can do your constants first if you want to. I always start with the variables because I like to see the variable only on one side. So if I start with my variable, subtract that 4x from both sides. Hold on. We're going to get 2x. I don't know why I wrote 20. I think I was looking at the 0 on the 40. 2x plus 40. What's going to happen on the right?
You're going to take away.
Well, we're going to break down that 80, right?
So it's 40 divided by 2.
So what's my next step?
40 by the front.
What do I do?
Minus 40.
Subtract, take away that 40. Subtract 40 from both sides. And that last step, divide by that 2. 40 divided by 2, exactly. We're going to get x is equal to 20. Okay? Now, I did want you to substitute in. We have just enough time. We want to substitute in for EFH, angle EFH, which is that 4x plus 80. So here, I'm going to go ahead. I'm just going to do it right underneath. I'm going to remove that x, and I'm going to put in what x was. Okay? That's that 20. And then I'm going to add 80. And what are we going to get? 160 degrees. Now let me ask you this. If the whole thing is 160 degrees, never mind, you beat me to it. What is each angle worth? 80 degrees. All right? Good job, guys.
Oh my God.